Hi guys, so in this video we're going to look at the next step in creating our app which plots quadratics. So at the start of this video I've got an app which looks like this. I've just got one box for A and I can click plot and I've got a line. So before I go any further I'm just going to add in the B and C part, so let's do that. Now I think the easiest thing to do here is if I create a subroutine, a function, which allows me to generate the text box and the text area at the same time. So that means that I don't have to duplicate so much code. So I'm going to copy this part of the code which creates the label. Now the label is going to be different in each case, so I've made label one of the parameters of the method. And then the return value is going to be the text area that I've created, because I am going to need to use that text area to get the parameters for the quadratic equation. So here is where I'm going to store the parameters A, B and C as text areas, and they should really be private. I don't want other people to fiddle about with those. So now up here I can do a text area equals add field A equals, and I put that at y coordinate 30. And then creating the text area for B is almost exactly the same, but the only difference is I'll change the letter and I'll change the y coordinate where it appears. So if I put that at 60 and that at 90, and there's my A, B and C. Okay, now the next step, inside the plot area I want to have a grid. So if I go to graph, I'm going to need to create axes first of all. Now the axes, the way that I want them to look is that I'm going to have the x-axis going horizontally across the middle and the y-axis going vertically through the middle. So have a pause and see if you can do that. Also we'll have the background color as white and the foreground color as black. So I want x and y axes, background color white, foreground color black. See if you can do that. Just pause the video for a moment. Okay, so guys, here's the solution. First of all, I need to set the color to white and fill in that rectangle so that I've got a white background. Now I'm going to set the color to black. I'm going to draw two lines. Now the first one, the x-axis, it will start from x coordinate 0, but then the y coordinate will be the height divided by 2. Okay, and then for the y-axis that's going to be width divided by 2, and the y-coordinate will be 0, and then width divided by 2 again, and the y-coordinate will be height. So if I run that, okay, and there's my x and y axes. Okay, now we can add some text to those axes. To do that, let's use a for loop. So I'll do for int x equals minus 5, x is less than or equal to 5, x plus equals 1. So I'm just going to do x values from minus 5 to 5 here. And then I'm going to use the draw string function, which takes a string and an x and a y coordinate. Now the y coordinate is the easiest one to do because that's going to be height over 2, right? Height over 2 is the y coordinate of my x-axis. The x-coordinate is a little bit trickier, but I know that the center of my graph is at width over 2, and then I probably want to add x multiplied by some value. Now that value is going to depend upon the size of my graph and about how spaced out I want the x values to be. At the moment I'm just going to pick let's say 50. Okay, now I also want a string for the label, so what I'll do is I'll create a variable called label, which is a string, and that's going to be integer.toString of the x value. So if I run that now, there are my x values. Now these are actually appearing above the line. I probably do want to set them on the line. If I remember rightly, there is a method where I can choose where I want the text to be situated, but I can't see exactly where that is. So if I can't see it straight away, I might leave it for now and look it up on the internet later on. Okay, I'll leave it for now. Okay, so guys, that gives me labels on the x-axis. Now please have a go at creating labels on the y-axis. Just pause the video for a moment, see if you can do it. Okay, so here we go. I'm just going to copy that, and then this time I'm going from y coordinate, and I'm always going to be plotting at width over 2, but the height is going to be, now it's not actually going to be plus y, because the coordinates for computer graphics go downwards as you move from the top of the screen. So negative numbers will be towards the top of the screen. In fact, they'll be off the top of the screen, and positive numbers will be towards the bottom of the screen, which is the opposite of a normal mathematical graph. So what I'll do instead is I'll change that to a minus sign so that we flip the y-axis over. Oh, I've made a mistake there. That's because that should be y. Okay, let's try that. There we go. Now my y-axis, because this graph is quite squashed, my y-axis doesn't really go up very high. I'm tempted to make that graph a little bit bigger. Let's go and make it bigger. So on screen 1, if you remember, I set the preferred size of the panel. So screen 1 extends a J panel, and where do I set the size of that J panel? Maybe it's in main. Yes, here we are. So I set the size to 480. Let's increase that size. Let's make it 800. Okay, so in that case I've added another 320 pixels, which means that my graph can afford to have 320 pixels added to the bottom. So where I create my graph, which is on screen 1, instead of 260, I can have 580 pixels high. Let's try that. Yeah, that looks a lot better, and there's more space for my graph now. Okay, now guys, we need to actually plot the curve. So I'm going to go back to graph. Now, just to start off, I won't plot the curve that the user's entered. I'm just going to plot a really basic curve of y equals x squared. So to do that, I'm going to need to have two x and y coordinates at any particular time. Okay, because I need to draw a line, and that means I need 2 points, a start point and an end point. So let's create a loop. I'll do for x1 equals -5, x1 less than or equal to 5, x1 plus equals 1. Okay, now what I'm going to do is I'm going to create x2, which will be x1 plus 1. So that gives me two x coordinates, x1 and x2, and now I'm going to work out the y coordinates that go with them. So y1 is going to be x1 times x1, because I'm just doing y equals x squared. Sorry, I took x2 there. And then y2 is going to be x2 times x2. So now I just need to draw a line between them. So draw a line, x1, y1, x2, y2. Now, this line, at the moment, it would be centered around 0, 0 on the screen, but 0, 0 on the screen is actually the top left of my screen. So I want to center it around 0, 0 on the graph. And of course that is at width over 2 and height over 2. So although this is starting to get a bit messy, at the moment I'm going to just write it out directly and we'll tidy it up afterwards. Now don't forget to flip that y-axis, because I almost forgot to do that here. Okay, let's try that, see what we get. And I've got a really small quadratic. That's because I'm not multiplying by the size of the grid. So I'm only actually doing, instead of going 1 unit on the graph, I've gone 1 pixel on the screen, and that's given me a really tiny little happy quadratic. So let's multiply that by the size of the grid. Now, to stop it getting any messier, because I'm already multiplying by all these different numbers, it's time to tidy up a little bit here. So each of my grid squares at the moment is 50 pixels, so let's set that as the x scale. Okay, so x scale equals 50 means each square on the x-axis is 50 pixels. And I can put that in there. And I'll also need to have y scale, which I'll also set to 50 pixels. At the moment we've just got squares on our grid, but later on we're probably going to need to adjust the to squash the graph so that we can see different types of graph. Now I think it will also be much neater if instead of all of these width over 2's, I actually create a variable. So mid x is width over 2 and mid y is height over 2. And then instead of doing all of these calculations each time, I can replace those. So let's use text replace. Height over 2 I want to replace with mid y, and width over 2 I want to replace with mid x. Okay, and I'll need to put these back. So mid x is width over 2 and mid y is height over 2. Okay, that's just a lot neater to write mid y rather than height over 2 every time. And because I've now got x scale and y scale, that means that when I do these calculations with x1 and y1, I can multiply these by the grid size. So x1 should be multiplied by x scale, and y1 should be multiplied by y scale, and x2 should be multiplied by x scale, and y2 should be multiplied by y scale. Okay, and there's my quadratic graph. Now you can see that the quadratic graph here, it's made up of straight lines. So this is because I'm only plotting, in fact, every 1 unit on the graph. So I've got kind of an ugly graph here. Now what I really want to do is to plot subunits. So instead of jumping from 0 to 1 directly, I want to go from 0, maybe 0.1, 0.2, 0.3, 0.4. And that means that instead of using integers, I'm going to need to use floats or doubles. So guys, that's the next challenge for you. I want you to have a go at using float or double to make that curve a bit smaller. I keep getting a funny error down here. I didn't actually see what the error is. It disappears really quickly. I don't think it's necessarily connected to my program. It might be a problem with Eclipse. Okay, so I'm going to ignore that at the moment since my program seems to be working okay. So we're going to try and smooth out this curve, okay, and we're going to do that by switching these ints into floats and then increasing by a smaller step. Rather than adding 1 each time, we're going to add a smaller amount. Pause the video if you need to, and have a go at that, and then come back when you're ready. Okay guys, so here we go. Let's have a go at solving this problem. So I'm going to use double rather than float because double is a bit more accurate than float. So I'll change all of these to doubles. Okay, and then because these are doubles, I can add something like 0.1 rather than just 1. Okay, now draw line expects integers rather than doubles. So there is actually a fixed version of draw line which accepts doubles, but I'm not going to use that at the moment because I want to concentrate on solving the general programming problem. So the general solution is going to be to convert those doubles back into integers so that we can draw the line. So what I'll do is I'll create a new integer. Let's call it rounded x1, and to round it I can use math.round. So then I take my x coordinate, I round it to a whole number and store that in rounded x1. I've got something complaining there, cannot convert from long to int. Okay, so it wants a long rather than an int. I'm going to have to cast that to an int, so I put int in brackets at the beginning and that forces it to be an int rather than a long. Okay, let's do the second coordinate. So there we go, there's the second coordinate. There's the third. I've not round. Oh, that's messed up a little bit. So it should be x2 times x scale. Yeah, sorry. And then rounded y2 equals int math.round. Okay, so once I've rounded all of those numbers, I can put the rounded values into drawline. Let's test it out. Okay, that has some funny effects. So why do I have those funny effects down the bottom? I'm just going to try to work out. It looks like the x1 and y1 or x2 and y2 might be slightly incorrectly calculated. Oh, here we are. It's because x2 I'm still adding 1 instead of 0.1. So this is the problem when you create when you just type in the number that you want at the time and then later on you decide to adjust that number, there's always the risk that you might not adjust it in every place that you used it, right? So when I changed that was originally 1, and when I changed it to 0.1 I should have also changed that to 0.1, but I missed it out. So this is why it's generally good to create a variable. So for example, step equals 0.1, and then it helps if I don't create an integer which is a decimal point. So then I can add that step in both places, and that means that if I want to change the step size, I just do it once up here, and everywhere that I need it is going to change. It reduces the probability of creating bugs in my program. And there we go, there's our nice smooth quadratic line. Now the fact that I've got these x scale and y scale values means that it's really easy for me, for example, to reduce the scale of the y-axis, and this is going to squash the curve downwards. Now there is a little bit of an issue because no, I don't get to see it. Okay, there is a little bit of an issue because although it squashes the graph down, which is great, my y-axis doesn't number right up to the top of the graph. So that's something which you can have a go at fixing for next time. I'll give you a fix a little bit later on if you're stuck, but I think you guys might be able to work out how to make sure that the graph always numbers right up to the top of the visible area. Okay, another thing to do for next time is when you enter the values of a, b and c into here and then click on plot, see if you can get it to plot the actual quadratic equation that's entered here. Okay, so at the moment we're just doing y equals x squared, and that obviously comes from these two lines here. So these lines are calculating the coordinates of y1, the value of y1 and the value of y2 based on the formula y equals x squared. But what we want is to have the general quadratic formula. So y1 is going to equal a x1 squared plus b x1 plus c, and y2 is going to be a times x2 squared plus b times x2 plus c. So if you implement this in your graph, so you need to take the values of the a, b and c that have been entered by the user and then set those in the graph. Okay, so you're going to need to probably use mutator methods there, and then when you click on plot you're going to update these equations with the values that have been set, so that you draw the graph for the a, b and c that the user's typed in. So guys, I hope that gives you some interesting ideas about how to plot this graph. There's still quite a bit to do before this is a polished app.